Welcome, everyone. My name is Sasha Codet, and I am a planner in the SAWS Conservation Department, and really glad y'all could join us here today. I'm going to be hosting today's webinar, and we're really pleased to have our very own Gregg Eckhardt joining us. And Gregg is an environmental scientist with 32 years of experience in environmental modeling and analysis, water resource planning and development, state and federal permitting, and water treatment. And he is known as the Nerd King of South Texas water history. So as senior analyst for SAWS, he's involved in the planning, operations, and management of the city's water supply and wastewater. So glad to have you with us, Gregg.
Glad to be here, Sasha.
Well, let's jump to the next slide and
Yeah.
we'll cover a few items folks need to know about. So we would love to hear any questions that y'all might have. So there is a Q&A box, and we'd like you to use that instead of the chat. And the Q&A box is located, if you click on those three little buttons, you should see it pop up there. It should be located at the bottom of your screen. And I do want to mention one other item. Today's program is eligible for our Water Saver rewards. And so keep an eye out and look for a code word that's going to pop up during Gregg's presentation today. And you're going to need that for the survey after the program. All right, so with that, again, we welcome your questions, and I'm going to go ahead and turn this over to Gregg.
All right, Sasha, thank you very much. And with an introduction like that, I can't wait to hear what I'm going to say. But so thank you, and thank you everybody who's joined us here today for this little talk on environmental flows and how much water a river needs, and what SAWS is doing to help there. And also at the end, I'm going to have talk about some things that you can do personally to help protect the river as well. So I had the privilege of serving on the state science team that answered this question about how much water should be in the San Antonio and Guadalupe rivers. And it wasn't really as a SAWS person, just as a science geek. So I wanted to show you the decision diagram that we used to answer the question about how much water should be in the river. And so don't panic about this, because what I'm going to try to do here today is simplify this and sort of give you a feel for how we went about this, how we answered this question of how much water should be in the river. Our saying about this diagram was E-flows, it's not rocket science. It's much more complicated. And it is, but I'm going to try to make it very simple here for y'all today. So the river basin that we're talking about here is the Guadalupe San Antonio Basin. And we think of them as two separate river basins, but they really are one, because the river joins together, confluences a few miles above the coast there, and then flows into San Antonio Bay, all as one river. So it really is all one river basin. Now, we have two entities that are managing each side of this river basin. On our side, it's the San Antonio River Authority. On the Guadalupe side, it's the Guadalupe Blanco River Authority. And I think it's fair to say that these two agencies have very different focuses in what they do. The GBRA has always been mostly about supplying water to customers and developing water projects. Whereas SARA, San Antonio River Authority, they're more about sustainability and environmental things and stewardship of the river. That's really their focus. And also, I think it's fair to say that the river stems themselves are very different. On the Guadalupe side, you've got storage in Canyon Lake, and you've got spring flows in New Braunfels and San Marcos. And you've also got a series of hydroelectric dams on the Guadalupe. So on the Guadalupe side, it's really a series of long skinny lakes on that side of the basin. And so because there's storage, because there's spring flows, the management and the in-stream flow issues are very different on the Guadalupe side of the basin than they are on the San Antonio. Well, here's one of those little hydro dams on the Guadalupe stem. But on the San Antonio side, during the dry times, almost all the water comes from our water recycling plants. So during those dry times, no spring flows, no storage really. Medina Lake can go dry. And so it's really almost all recycled water from our plants on our side of the basin during those very low flow periods. So and this is why SAWS is involved with the management issues for flow in the San Antonio River on our side of the basin. So here's a little graph in which I've traced out the various pathways by which a drop of rain can get to the ocean. And as you probably know, in Texas, we have two different legal regulatory systems for surface water and for groundwater. Groundwater is owned by the landowner. If you own property, you own the water underneath, whereas surface water is owned by the state. So in this graph here, the blue lines are surface water owned by the state. The green lines are groundwater owned by the landowner. So you see that the same drop of water changes ownership many times before it gets to the coast. And this is a very challenging environment in which to manage any water resource and develop any water resource project, because we have these two different legal regulatory systems for surface water and groundwater. It's very challenging to do conjunctive management of both of those resources. So as far as environmental flows go, you're going to hear me talk about two legislative programs for environmental flows. The first one was Senate Bill 2 in 2001, called the Texas In-Stream Flows Program. And under that program, the agencies, they determine what flows are necessary for the river. This is the Texas Parks and Wildlife, Texas Commission on Environmental Quality. The agencies do the studies and make designations about what constitutes a sound ecological environment. And they will consider stakeholder input, as it says there, but I've been to all those meetings since they started in 2001, and they do listen to stakeholder input, but for the most part, they know what they're going to do under this program. Now, the Senate Bill 3 program that I'm going to talk a lot about, called the Environmental Flows Program, is very different. It's not driven by the agencies, it's driven by stakeholders and by the science team that I served on. And so what the stakeholders were charged with doing and the scientists were charged with doing was coming up with the flow regime that's necessary for the river, and balance those interests between environmental and human needs. And I will say that for this Senate Bill 3, our own president, Mr. Puente, when he was in the legislature, he was the House sponsor of this Senate Bill 3, and he considered this one of his signature accomplishments. So he's very supportive of this whole environmental flows program. We're lucky to have him working for us here. So, but it started with Senate Bill 2. And so what they did was they designated some priority areas, which are outlined in red here. You see the lower Guadalupe and the lower San Antonio River were priority study areas under Senate Bill 2. So that's all well and fine, but beyond that, the state did not allocate any money. They allocated $0 to actually do any Senate Bill 2 studies to determine flow needs. So the San Antonio River Authority stepped up to the plate, and they paid the cost of doing all of this Senate Bill 2 field work on our side of the basin. And it starts with just doing a lot of fish sampling and seeing what you got. So they collected some 12,000 fish samples just to start to quantify, what species are living in the area. And then what you do is you start breaking up the fish that you're finding into these different guilds, depending on where they're living. So here at the bottom here, bottom left, this is a low velocity, high depth. So those are deep pools. So you've got certain fish that are utilizing that habitat. On the other end, you've got other species that are using fast riffles. So you're starting to figure out what you've got, what kind of fish you've got, and what sort of habitat that they're using. And the objective here in both Senate Bill 2 and Senate Bill 3 is to define the master variable. So in an aquatic ecosystem, the master variable is flow. Everything else derives from flow. So that's what we're trying to do is define the flow needs, define the master variable, and we're trying to determine what is the link between the flow and the biotic response of the fish and the organisms in the river. The bottom line is that's what all this is about, is trying to figure out how the flow affects the biology in the river. So one reason that chart I showed you was so complicated is because as far as what the flow needs in the river are, it's not one number. There's all these components to a flow regime. There's subsistence flows, base flows, pulse flows, overbank flows. So I want to talk a little bit about each one of these in turn, starting with subsistence flows. These are very low flows. They don't happen very often. They might happen in July and August during an extreme drought. And you know, when you see a stream on the news that's under subsistence flow conditions, very low flow conditions, it looks terrible sometimes. But when these happen, they're really not that bad, because they will do things like kill off the non-native species. They can't tolerate those kind of conditions, but the native species are adapted to that and they will survive. So as far as subsistence flow numbers go, what you might do is you might set a value such that at the bottom here, you don't dewater the entire root zone of the trees so that they will survive that very low flow condition. You're looking for there to be no permanent damage from those very low flows that happen sometimes. And then you've got base flows. This is where the water is about up to the normal vegetation line here. So these are what you would call your normal flows there. And but once again, it's not one number. They vary by season, they vary by hydrologic condition. But what you're doing is you're trying to make sure that there's adequate habitats for all of those different types of fish that you've been finding. And then you've got pulse flows. These are flows that happen after a storm event. So they're very short duration. The water is above the vegetation line, but it's still within the channel. And these pulse flows that come through after storm events, they have all kinds of ecological functions. They move sediments, they move nutrients, they give fish spawning cues, they disperse seeds. They have all these functions. They maintain the river channel by scouring. They provide a longitudinal connectivity down the length of the river. There may be like an abandoned oxbow on the side of the river that normally doesn't have much water in it, but it'll get some water in it during one of these pulse flows, and then it'll serve as a nursery, a hatching ground for all sorts of fish. So these pulse flows have really important ecological functions. And then you've got your overbank flows. These are floods. This is where the water is out of the channel. They don't happen very often, but these flood flows, these overbank flows, they have ecological functions as well. They help maintain the riparian zone on either side of the river. They provide a lateral connectivity across the river. You have areas on both sides of the river that are normally not connected, but during flood flow conditions, they are connected. So these, believe it or not, floods have ecological functions as well, and all of those flow components have functions. So this is the San Antonio River at Falls City, and this is the only place on the San Antonio River where it splits into 3 channels. So it's a very sensitive area. This is one channel here, and the second channel, the third one is off in the background here. It's the only place where this happens. So under Senate Bill 2, what they did was they built a model of this site because it's a very important site. I was standing on the bank over here, right about here, looking downstream. So at a flow here of 89 cubic feet per second, you determine what sort of habitats that you have under those flow conditions. So you've got pools and riffles and runs here, and then at a higher flow rate at 250 CFS, you're starting to see some backwater, and the areas start to change. and then at a higher flow rate, 385 CFS, they change again, and then at a higher flow rate, they continue to change, and through all these different flow conditions, the habitats that are available will be different. They'll be in different areas. So then what you do is you develop a graph like this, and you're plotting the flow against the percent of maximum available habitat, and you're looking at how the habitat changes when the flow changes. And so then, and this is where the fish people on the science team came into play. This is scientific, but there also is just some judgment involved here, some expert judgment. You know, the experts look at this and say, well, it looks to me like you would set the base flows in about this range, and the subsistence flows in about this range here, because you want to have subsistence flows that are enough to, you know, maintain some of the deep pools. On this end, this is in the red here, those are deep pools. There's very few of them, but you've got some. So there's some judgment in this, but this is a good way when you have all of this data about what the fish are and where they're living. It's a good way to determine what the flow needs are. So that's all well and fine if you have that kind of information. But for most sites on the San Antonio River, we did not have that kind of data under Senate Bill 3. So, and I don't expect you to be able to understand this. I'm going to show you what it really means in a second. So we started with a hydrograph separation model. We're taking the historic flow record and dividing it up into those four components. You see subsistence flow, base flow, high flow pulses, and overbank flows again. So I've taken that graph, that model output, and graphed it for the Elmendorf location. So historically, this is what the flows that the river has seen at the Elmendorf location. And once again, you see your subsistence flows, which are the low flows in the red line here. You've got your base flows, which are the flat areas. You've got your pulses, which come through after storm events. And then the overbank flows, where I've lopped off the peak here, but you get these very high flows that happen occasionally when we have floods. So then you start asking yourself the question, well, what else should we consider? So you start doing overlays, and so this is the Elmendorf location where that flow regime was measured. And so you start asking yourself, what else do I need to consider besides the flow there? And on the science team, I was the water quality guy. So we overlaid water quality on this and ask yourself, is there some sort of water quality concern that might cause you to change the recommendation based on that model output? And there are people that specialize in riparian zones did the same thing, and people that specialize in geomorphology, the shape of the river and sediment transport. So you do these overlays and perhaps make adjustments to the flow recommendations. And we did that. We identified that for water quality, I found that under very low flow conditions, the dissolved oxygen here was too low to maintain the fish species. So we revised the flow recommendation upwards. So we made recommendations like that for 16 sites throughout the basin. Only one of them, that Falls City location, we had that Senate Bill 2 study to inform what we were doing there. For the other 15 sites, we used that other process where you look at the historical flows and then you do overlays on top of it to try to identify reasons why you would make some changes to the flow recommendations. And we also made recommendations for inflows to the bays and estuaries. And Senate Bill 2 didn't do this part. So this was important for Senate Bill 3 to do this. That's part of the equation too. And what we did there, it was very different. And I don't want to get into the weeds of this because this really was complicated. But we looked at two different species of organisms there, the Rangia clam and the eastern oyster. And they have very different salinity requirements. So the salinity in the bay that's perfect for one will kill the other. And so we looked at in the long term, what sort of salinity do these species need to be able to bounce back from a change to the salinity that the other species needs? And once again, you're trying to um, balance it such that there's no permanent damage from some long period of high salinity. So we made recommendations based on things like attainment frequencies. So for example, during the spring months, we'd like to see a certain volume of water get to the bay in 10% of years. And in 15% of years, there may be a different volume of water that we'd like to get to the bay. And once again, it's about providing some natural variability, because that's what the species here are adjusted to. You know how rainfall is here. We go for long periods where there isn't any. And so there is a lot of natural variability in the ecosystems here. So once you know what the flow numbers are, and the end result of that process was that the state adopted in-stream flow standards for the San Antonio and the Guadalupe River. So once you know what the flow numbers are, the question then becomes, well, how do you make those numbers happen? Is there some sort of endangered species hammer to make those flow numbers happen? And the answer is no. At the same time we were doing all this work, there was a lawsuit going on over the endangered whooping crane. And the short story is that the birds lost the lawsuit. But this is what the judge said about Senate Bill 3. She said, Senate Bill 3, it establishes a framework for determining the amount of flows that need to remain in the river, but it doesn't make any attempt to ensure that those flow numbers actually happen. And that's true. There is no requirement for anybody to do anything under Senate Bill 3. Today, it is all voluntary. So the legislature asked the stakeholders to keep working and to come up with a recommendations report that outlined things that people could do voluntarily to meet these in-stream flow standards. There's nothing required. And the stakeholders were from all over the basin. They were the captains of industry and the environmental groups and the water purveyors in the cities and such. And they all recognized that on the San Antonio side of the basin, where the river depends on water from saws during the dry times, they all recognize that dedications of recycled water, of wastewater effluent, that's a key strategy. It's a key strategy in this recommendations report for making these in-stream flow numbers happen. And that's where SAWS's dedication for water to the river comes in. We applied, and I think this is one of the most significant things that I've worked on in my 32 years. After we finished up this environmental flows process in 2013, SAWS applied for what's called a bed and banks application, a bed and banks permit. Now, as I mentioned, the state owns the river and they own the water in it. But the private landowner like SAWS, you own the groundwater. So the state will let you use the bed and banks of their river to move your groundwater downstream for some sort of reuse. And that's what this permit does. So we filed this application in 2013, and we told the state that we wanted to dedicate 50,000 acre feet a year of water for in-stream flows. And beyond that, we told the state we wanted to protect ownership and control of all of our groundwater-based discharges, all the water we're producing from our plants. We're almost all groundwater even today. So, oh my gosh, there's something popping in there that you might want to write down. Now, these bed and banks permits, they're fairly common in Texas when people want to do reuse projects. If you want to say, move your water from your plant downstream to water a golf course or something, you get a bed and banks permit for that. But it is very uncommon to apply a bed and banks permit for in-stream uses, especially at this scale. We're talking about a 50,000 acre feet. That's a lot of water. And so this is one reason that the water lawyers are so excited about this, because this is unprecedented in Texas. Nobody has ever done anything like this before. This is really at the cutting edge intersection of how you conjunctively manage groundwater and surface water. So there's a lot of people who are watching how this progresses and how this is going to shake out at the state, because this is just unprecedented in Texas for somebody to voluntarily make a commitment of water like this and use a permit like this to make sure that it gets to the, stays in the river and gets to the coast. So we saw this clip before, but it's worth looking at again. What I want to point out here is that at the top of the outfall structure there, where the water's going into the river, that's almost all groundwater. And that water belongs to our community. It belongs to, you know, you guys, the people that have paid billions of dollars to develop that water in the first place, and billions more to treat it afterwards. It belongs to you. But at the bottom of this outfall structure, the way it works today is that water belongs to the state of Texas. It no longer belongs to us and you in San Antonio. Well, this permit will change that. The law allows you to retain ownership and control of this water after you put it in the river. And that's why we're doing this. So this is a really innovative strategy. Like I said, nobody's ever done anything like this before. This protects a very, very valuable water asset, 50,000 acre feet. And just for comparison purposes, I'll point out that our Vista Ridge project, which I think is $2.1 billion, that's also 50,000 acre feet. So very, very valuable water asset. Making this dedication will protect the San Antonio River, the bays and estuaries, and also the economies of the cities down there that rely on freshwater flows. So the key features there, as you see it does protect ownership and control of all the water we're producing today, all the water we're producing tomorrow, to the extent that it's groundwater, and it supports the Senate Bill 3 stakeholder recommendations for meeting these in-stream flow standards. Now, we're doing a lot of things with our water here in San Antonio. You know, we've got the nation's largest purple pipe reuse system. We've got about 70 customers on this system. Trinity and the Alamo uses it on their grounds there, and the Toyota truck plant uses about 1 million gallons a day in their painting shop. And we're also using this recycled water to maintain flow in the upper San Antonio River. This is in Brackenridge Park, where we're putting water in. And also this is at the convention center. And so on a dry weather day, when it's not raining, almost all of the water in the beautiful downtown San Antonio Riverwalk here is recycled water from our plants. So next time you're at Casa Rio restaurant there, you can tell your friends that water was flushed about 2 days ago. And we treat it to almost drinking water quality, by the way. Another thing we do with our water is we supply all the water that CPS Energy uses to make electricity. It takes vast amounts of water to make electricity, and we provide that to them by releasing it from the plant into the river, and they pick it up a few miles downstream, and they put it up into Browning and Calaveras lakes. So this is how our supply of this recycled water breaks out today. In a very dry year, we've got about 125,000 acre feet of this recycled water. And so of that, we have a contract with CPS for 50,000 acre feet. We've got 25,000 acre feet for our purple pipe reuse system. And so what's left over is 50,000 acre feet in a dry year. And that's the dedication. So we're taking all of the water that is uncommitted today and dedicating it for the river. Now, in the future, we expect that the supply of this water is going to grow as the city grows and uses more water. And so when it does, the supply of this water will increase as well. And that may take some decades. So it will be the people after us. It will be the next generation that decides what to do with that water. But the key thing about this permit application today is that it will protect that water for the future. So those people after us, the water managers of the next generation, they will get to decide what to use that water for. We just want to put our thumb, our stamp of ownership on this water today. so that they have that very valuable asset to work with in the future in San Antonio. Well, one thing we heard from the state was they told us that we had to actually have a physical diversion of the water. They said the statute requires that. And so the San Antonio River Authority brought this to our attention. And this is a situation that really works out great for everybody. This is the historic delta. You see how the river channel here, this is the river that breaks into these tendrils that looks like a bird's foot. This is the only bird's foot delta on the Texas coast. It's all owned by one family. It's called the Swan Lake Ranch. But the thing is that the water, it doesn't go this way anymore. It goes this way, where the green line is here. That is an artificial cut called Trailer's Cut. That cut was made in the 1940s. They tried to dry out the delta for rice farming. So the water today is not going over the historic delta like it used to. So the delta there is being deprived of fresh water, of sediments and nutrients and such. And so what the River Authority pointed out to us is that the ranching family, they have an airboat canal. That's this white line here in the picture. They have an airboat canal here that goes back up almost to the river and then goes to this central lake. So our plan, since the state told us we had to actually physically divert the water somewhere, the plan is to pick the water up here, put it in this airboat canal, and then it will go into the bay. And it will also have the function of supplying sediments and nutrients and fresh water to the historic delta system here. You know, they're losing the fringes of the ranch here to erosion because it's just not getting the sediments and such that it needs. So all of this worked out real good for everybody. We needed a diversion, the state said, and the ranch needs fresh water and nutrients for the historic delta system there. So this is just a typical screw pump type mechanism that we would use to pick up the water from the river and put it up into this airboat canal that then goes down into the bay. So we did a tremendous amount of public outreach on this application in the early days. And I look so much younger there from 5 years ago, but I spent about 18 months with the regional outreach boys, and we talked to anybody who would listen in the basin about this project. You know, chambers of commerce, county judges, economic development corporations. We would start talking to the locals in the McDonald's during lunch if they would listen to us about this. So we would describe this project to them, and then we would ask for their support. And we ended up getting 17 resolutions of support for this bed and banks application. And just recently, just this summer, when we finally got a draft permit, we got 11 more letters of support for this. So there's a tremendous amount of support throughout the basin for all this. You know, a lot of people, they just see that it has benefits for everybody. You know, if those people in Rockport, Port Aransas, they get it. They know how important the effluent, the water from San Antonio is to their economy. And so they understood the environmental part of this. But the reason that a lot of these people supported us was because of the economic side for them. You know, the charter boats down there in Rockport, the shrimping industry, the oysters, it all depends on freshwater inflows from the river, which to a large degree is San Antonio. So they supported us because to them, they saw this as an economic thing primarily. And these are people who they don't feel like you have to pick between the economy and the environment, because what's good for one is good for the other. So that's the idea, is that we're going to get this permit to protect this water so nobody else can take it before it gets down to San Antonio Bay. And, you know, there's a lot of support for this out there, but it's not universal. There are some people who are going to oppose this. There are some entities that they want the water they want our water, your water, for their own water projects downstream. And so it's very likely that this is going to be contentious. You'll hear about it in the media over the coming next couple of years. But we think it's the right thing to do. we want to protect this water. This is water that we own, that you own. We want to protect this water for you, for our community, and we're just not apologizing for that. And we also want to make sure that we do our part to get this water down to San Antonio Bay, because as you probably know, the whooping crane there does depend on freshwater inflows. And this water will come out in San Antonio Bay right adjacent to the whooping crane habitat there at the wildlife refuge. And there are other species that are of concern as well. And one way I sold this to the executives in the very beginning was I said, look, it's not out of the realm of possibility that someday we'll be required to put water into the river for the sake of some endangered species. At that time, the mussels, freshwater mussels, were being considered for listing. And just a few weeks ago, they were proposed to be listed as endangered. And so what I told the executive was, let's just get out in front of this by a couple of decades. And, let's do this 10 or 20 years before a federal judge tells us that we have to put water in the river for the sake of some endangered species. When and if that day comes, well, we'll be able to say, well, we're already doing that voluntarily. It's just the right thing to do. So where we are now in this application, we filed it in 2013, and we're 8 years later. We got a draft permit this spring, and they gave us everything we wanted. We really liked the draft permit. And so we told TCEQ to go ahead with processing. We just finished a public comment period where people had a chance to comment and ask for this thing called a contested case hearing. And that's why we know this is going to be controversial, because those entities that want this water for themselves, they have requested contested case hearings. So it remains to be seen whether they will actually get one, but that will be determined probably here in the next 6 or 8 months or so. TCEQ, they don't really have a set timeline for this. It's kind of at their discretion, but within the next year or two, we will hear a lot more about how this is advancing. And then we'll go through the rest of the process where TCEQ will issue the permit. And at that point, this water will be protected for our community for now and for the future. So I just have a couple of things left to talk about here. And I think I've already talked about these. There's three places where the water can go today, recycled water. And, it either goes to CPS Energy for electricity, it goes into our Purple Pipe system, or the water goes into the San Antonio River. And what I'm getting to here in this part of the show is things for you to think about, things that you might consider doing to help protect the river yourself. And so I want to talk very briefly here about using gray water. This is water that you take in, from the sink, not toilet water, but from the sink, from the shower, and directing it out onto a landscape. And, I'm kind of against it personally, because, well, first of all, you sort of have to be an engineer, to pull that off. But what I want you to think about, and just keep in mind that it is a zero-sum game. If you're sending water out to a high water using landscape with gray water, or even, especially during the very dry times, then that is water that is not going to CPS, it's not going to the Purple Pipe, and it's not going to the San Antonio River. I would much prefer that you send the water to me. We just rather have you use, do a low water using landscape, and send the water to me. And when I get the water down at the plant here, my office is right here in this building, by the way, for the last 30 years. When I get the water down there, every single drop of it goes to a beneficial use, one of those three uses. And I think that all three of those, CPS, Purple Pipe, San Antonio River, all three of those are better uses than a high water using landscape. So just think about that. I just want to ask you to think about that if you're considering gray water. So, and that's especially a concern at the very low flow end of the spectrum, when there's not a lot of other water in the river it's very important that we get all that water down there so we can put it in the San Antonio River. And then on the high flow end of the spectrum, when it's raining a lot, there are things you can do in your landscape to let the water soak in. This is a picture I stole from the San Antonio River Authority webpage. They have a whole section there about letting it soak in. That's the key thing with stormwater, is to keep it from running off. This is a bioswale feature at a subdivision here. So these sorts of features, what they do is that first of all, they slow water down, they get it to go in the ground, and they also purify water before it then gets released and ends up in the river. So this is something that you could do at your house to help improve the quality of water in the San Antonio River, is some sort of bioswale like this. This is a wedding in my own backyard a couple of years ago. So I have an acre out here in Helotes, and well, first of all, I just left it as a wildscape, but I wanted to make some paths and some trails, with some destinations like a picnic table and a grill here. And so I built these rock lined trails and lined them with mulch, but they're designed to intercept the stormwater. So they're designed to be perpendicular to the stormwater flow, so they stop the stormwater and get it to go into the ground. And that's the key, is just getting the water to go in. This is a question that I wanted someone to ask so bad, I decided to ask it myself. Can there be too much water in a river? And the answer is yes. This is the San Antonio River down near Floresville. And you see how, because of all the concrete in San Antonio, the water is running off all in one big vast volume and hitting the river and causing this erosion downstream. So very close to the next time we get a big flood, this ball field in Floresville is going to go in the river. So, and this is not how the river should be. There should not be this type of erosion. So, and this comes back to managing stormwater, getting the water to just soak in and go into the ground. And that's something that you can do. And finally, the very last thing I want to talk about is salt. And, I'll bet that none of you has a grandmother who had a water softener. But today, they're very common. They're like standard in new housing developments. So what I want you to think about is that all that salt, all those bags of salt that you see there in the HEB, the Home Depot, every single bag of that salt is going into the river. And when you look back at our concentration, we call this total dissolved solids. Salt is a component of TDS, total dissolved solids. This goes back 25 years. In the 1990s, our TDS concentration was in the 600 range, but look where we are in recent years. We are approaching the maximum amount of salt that the San Antonio River can take and still be healthy. So I want you to think about that. If you have a water softener, there's things you can do. You can optimize it. Well, you could, first of all, not have a water softener. If you have one, there are things you can do to optimize it. Make sure that it's regenerating based on the amount of water used, not just strictly on a timer. I think you're going to see saws talking a lot about this issue of dissolved solids over the next 10 years. It's becoming a very big issue for us at the plants. Because of this trend, the last time we renewed our state permit for the Stephen M. Klaus plant, we were required by the state to do a source identification study. So, we know a lot of this salt is coming from water softeners, but where else? What other industries? What else is contributing to us to this? We're in the midst now of a 3-year study to figure out where all the salt is coming from. And after that, I think you're going to see saws really get in the business of trying to communicate with our community about this developing salt issue for the river. So that's all I have, Sasha.
Great. Thank you so much, Greg. That was really interesting to hear the science behind it and all the long-term planning that's going on. And again, I do want to let folks know that this is a Water Saver Rewards eligible program. So if you are a SAW water customer, residential water customer, go ahead and join if you're not already a member. You can sign up online at our website, which is gardenstylesa.com/rewards. And how it works is that you attend different approved events and workshops and webinars like this, and you collect points for the ones that you attend. And when you get to 3 points, you'll receive a $30 rain barrel or garden tool coupon. When you get to 5 points, you can get a $50 mulch or compost coupon. And then when you get to $70, we have a coupon for many different water saver, gardening, conservation materials. So it's a great program to join. And after this presentation, there should be a link that pops up that will take you to a survey where you just answer a few questions, and then make sure that you write down that rewards code there, SA River. And you're going to need to enter that in the survey to get your points. One more quick reminder is that the survey does end at midnight today. Let's go ahead and click to the next slide. So if for some reason you end up missing that survey at the end of the webinar, we also have a link to it on our garden style events calendar in that calendar entry. So you can always go back and find it there. Just make sure you write that code down, SA River, so you'll have it with you. So yeah, I do want to also encourage folks to explore our Garden Style SA website. We've got lots of great tips for water saver landscaping, creating bioswales, as Greg was talking about, so definitely check it out. And so now I think we have time to take a few questions, if you don't mind, Greg. Well, let me start. So first, how will you measure the water going to the bay?
How will we measure water going to the bay? So that's a good question, and I think I have a slide here that will answer that. So we had to include in this permit what's called an accounting plan. And so we have to measure how much water we're putting into the river, say at the plant sites, at the convention center, at Breckenridge Park. And so we know how much water goes in. And then we have to account for natural evaporation and transpiration along the way. So that's in the accounting plan here. And then we also have to account for other water rights permits that might rely on our water. Like for a permit we have for water in Breckenridge Park, it relies on our effluent. So we make subtractions for those things. And then we subtract the amount of water that CPS Energy uses here. And then we apply another, what's called a conveyance loss coefficient from between CPS and downstream. And that tells us how much water we have available downstream of us to divert. So it will all be accounted for. There's this whole procedure we'll have to go through daily of figuring out how much water is ours downstream at the bay. Did I answer your question?
Great, thank you, yes. One more question there. Are the flow standards for rivers sometimes changed and revised? And if so, how is that done?
Well, that's a good question too. Let me see. I think I have a slide here. Oh, let me go to this one. Let me bring this one back up. So when we were doing this environmental flows work, there were a lot of things that we wished we knew more about. And so in the years since, the legislature has given us a couple of $1 million each biennial to do some additional studies. And the San Antonio River Authority has done some additional work. This is just a partial list here of all of these studies that we wished we had when we made the e-flow recommendations. So then the question becomes, well, how do you incorporate this new information, this new science into your environmental in-stream flow standards? And I will say that that's an issue where the legislature did not really neatly tie the ribbon and tie up the bow and provide any guidance on how that is done. And so that's one thing I think that the stakeholder group for Senate Bill 3 is kind of struggling with right now is how do you incorporate this new science to make any recommendations about changing the standards? And you know our terms as science people are expired. They don't even have a science team available to them anymore. And so a handful of us have said, well, we're going to continue to work to support you however we can. They rely on the science people, you know, the stakeholders rely on the science people to inform them about what this science means and how we might use it to make environmental flow recommendation changes. So the short answer is we're just not sure yet how we're going to incorporate all this new science to perhaps revise the standards in the future. And we might have some people on the line like Rebecca from Sarah who can chime in here as well and knows as much about this as me. So
Great. Well, let's see here. I do have a few more questions coming in. Greg, as our city grows with more homes being built, what will happen if our salt levels continue to go up?
well, what will happen is eventually you will get a permit limit for that. And this will be a limit, a standard that you get in your discharge permit, and there are consequences for exceeding that. So the very difficult thing about dissolved solids is that our treatment plants, they don't remove that. There's no treatment plants that are designed to remove dissolved solids. To remove those, you have to do a reverse osmosis. So the same process we're using at like our desalination plant. And if you're going to do that, well, then you might as well drink the water. So it'd be very, very expensive to treat this water to get the TDS down to where we need it to be. And that's why I think you're going to see saws focus on the source. We got to go to the source, these water softeners, the industries, and get the salt out of the water there. Because once it's in the water, it's very difficult and very expensive to get it out. But we are going to have to do something about it, I think is a short answer here. In the long term, you know, the river just cannot sustain these increases in dissolved solids that we're seeing. Did I answer your question? Okay.
Yeah, I think you covered
Okay.
it. Okay, next question here. Is it true that the water saws releases from the wastewater treatment plant, a big part of the river volume south of San Antonio, is cleaner than the water that enters the river from runoff?
Well, that is very true. I think I mentioned that we treat this water to almost a drinking water quality. You know, the water that runs off of and enters the river has, you know, from agricultural fields has pesticides and nutrients and phosphorus and all these things. And you can see this at the mixing zone where the water from our plant goes into the Medina River at the Stephen M. Klaus plant. You can just visually see it, that it's higher quality water than the background water that's coming in from upstream. We have to do at the plant, we have to do what's called a biomonitoring test every 3 months. This is where you take some very sensitive species of fish and you put them in water and you see how they grow and reproduce. And normally what you want to do is you want to use a mix of water that represents how much of your water is in the river and how much is, you know, other water. Like say it's 50-50. 50% your water, 50% runoff. You'd want to use a 50% mix to do this test. The problem is when we do the water 50-50 at our plants, these fish don't survive. So we use 100% effluent. We use no dilution. We put them all in straight effluent water, 100%, and they do just fine. So yeah, very high quality water.
Great. All right. So can you tell us why is there a requirement to have a physical diversion? If it wasn't put back into the river, recycled, or for CPS energy, where else would it go?
Oh, if it Well,
Two parts to that maybe. Why is there a physical diversion? And
this
then,
is this is just the way that the legislation was written. It was, yes, it was written primarily for people to use to send your water downstream and divert it for something like a golf course or something. So according to um, TCEQ, a diversion is required for this water. Now, we think there's other interpretations there, but we didn't want to fight that battle. And so we just decided that if we can work within the constraints that they say we need to work within and do a diversion, we'll do that. And as it turned out, we're able to do a diversion and actually have some additional benefit for the Delta system there, because we're putting water up into the Delta that's being starved right now. So it worked out pretty good. But, that could be something that the legislature will look at in the future, is if somebody else comes along and wants to, dedicate some water, some of their water for environmental flows, why should they have to divert it? Why can't they just leave it in the river? That's a very good question, and it's possible that the legislature will address that. I know that the environmental groups are asking exactly that same question, and they'd like the state to change that. Now, what was the second part of the question?
yeah, I think you might have covered it. It was why is there a requirement to have a physical diversion? And then if it wasn't put back into the river, recycled or for CPS, where would it go? So I
Oh,
think you covered both
well,
parts.
if if it doesn't go to CPS, then or to the purple pipe, it goes down the river today. And but the thing is that that water, it's not protected today. It belongs to the state of Texas, and anybody downstream that has a water right can take that water. And there are entities, like I said, that they want that water for their future water projects. So if they take it, then this water will not go to the bay. And that's why we want to protect the water so that it goes to the bay. Another way that I sold this to the executives was, well, look, if we don't do this, then those other entities get our water, and then a federal judge comes along and says that we have to put some water in the river. So then we have to make a further commitment of some future water for the river. So it's best to just do this with the water that we have available today, make this dedication, and make sure that it stays in the river.
Great. We have a couple more questions here. And actually, one, could you go back to the slide with your contact information? It looks like we have a question from somebody who would like to have further discussion with you. And so there's Gregg's contact info. Okay, here, next question. How do we incentivize or mandate developers with both commercial and residential to implement low impact development to help treat the runoff from their design footprint?
Well, gee, that's I don't know the complete answer to that. There are things you can do in the Unified Development Code to encourage that. You can offer incentives. It's the San Antonio River Authority who is way more focused on that question than SAWS is, because they are just all about how managing stormwater flows, and managing the water that gets in the river, and it does all go back to how you're using the land, how you use the quality of the river is a reflection of how the land is used around it in the whole watershed. And so that's a bigger issue than SAWS. That's really for Sarah, for the county, for the whole region, is how do we manage our landscapes across the whole region for better water quality, and how you mandate that. I don't know. I'm not a politics guy. I'm a science geek. So yeah, I just don't know. I know it's difficult and it takes time.
I have another two-part question in here. Are entities like Trinity using recycled water required to reduce their use during low flow times? And then I'll
Um,
give you the second part after, maybe.
okay. So if you're a recycled water customer, every one of our customers has a contract. that outlines volumes that they can get by month. So that's what they get. And the answer is the answer to that, short answer to that is no. They are not subject to those same sort of watering restrictions and cutbacks that you are if you're using drinking water. The recycled water it's a different animal, and so they know what they've got. They know what they've got in their contract, and they can use that even if it's the middle of August.
Great. Second part of it was, how long after a storm is it safe to go swimming in the river due to runoff?
Well, so what happens when you have a storm event are there are very large influxes of bacteria. And that's the main concern with people actually getting in the river. You don't see people in the water when you go down to the Mission Reach of the San Antonio River or in Breckenridge Park, and that's because of this bacteria issue. So this is an issue that a lot of people have been looking to address for a long time. I started working with the River Authority in the 1990s with sampling and quantifying what the bacteria levels are. And then the rivers were designated as impaired for bacteria. And when that happens, you're required to do a study about what the bacteria sources are. And then you're required to do an implementation plan to reduce those bacteria sources. All of that took about almost 20 years. Just a couple of years ago, we finally got an implementation plan in place to address the bacteria question. So it's going to take some time, but the hope is in the long run, I think, that we will be able to, reduce bacteria levels enough such that it's safe to go back into the water. There's a difference between stormwater, flows and normal dry weather flows. And, one of the things we looked at was, well, when they figure out the average for bacteria, they're including these very high flows with very high bacteria levels when there's not going to be anybody in the water anyway. So why not just look at the low flow periods and measure the bacteria there when you go about answering the question, is it safe for people to get into the water? So there are a lot of people that are looking at that question of how do we get there? Do we change the regulations? There's lots of practices we can do to reduce the bacterial loads, and all of those things are being looked at. I know that it's one of Sarah's main goals is for people to eventually, be able to get back in the water in Breckenridge Park and downstream.
Great. Thank you so much, Greg. Well, I know I want to respect everyone's time. I know we're running a little over here. Thank you all so much for joining us today. A big thank you to Greg for this fantastic presentation. If we didn't have time to get to your questions today, Greg's contact information is there on the screen, so you can go ahead and shoot him an email or give him a call. And remember that reward survey will pop up after and enter that code SA River. Thank you all again so much. Thank you, Greg.
Thank you all. Thank you all for joining. And hello to some of you out there. I see names of people I've known for a long time, Kevin and others. Thank you all for joining us today.
Thanks, everyone. Bye-bye.